Hi, today I will explain depth first search or DFS and how we use it to find all the possible paths in a graph. First, we can imagine DFS as all possible ways to go from A to F. In this case, I'm going to show how we graph a path and all the multiple ways we can go. And we run this, and we can see that there are two different paths from A to F. That it's from the node A to the node B, from the node B to the node E, and from the node E we get to the node F. The alternative path and shorter path will be to go from node A to node C, and node C directly to node F. We can see that the time it took was zero point 0.3 seconds. And if we try to graph or to get the path in a bigger graph with multiple nodes and different repetitions, we can see that there are multiple extensive ways and the time it took was bigger, 1 second and change. So how does it works? First, let's look at the Python code that implements that DFS to find all the paths from one node to another. This one right here. So we get the graph start, end, and the path. We go each and every from one node to another, recording every change in a single um, in the memory. And once we get to an ending, we trace back and go again, changing to different nodes. And once we get every single option, we can only return the paths where my start and ends, and then goes with what I am asking right here. So in this case, we go from the path and start to the going through every single combination, explain and try to explain the time and space complexity. We saw in the example that uh, the first run that goes from A to F was quicker than the one that was from A to Q. And this is because when a graph has only a few connections, the DFS is fast. But when every node is connected to every other node, the DFS explores more paths, so it becomes slower.